Hey, and good morning. Welcome to the Level Up Hour, where we contemplate containers, consider Kubernetes, and opine over all things OpenShift. I'm Randy Russell, the Director of Certification at Red Hat, and a special greeting to all the Red Hat certified professionals out there. And I'm joined by my co-host, Mr. Scott Stabby McBrien. Hey, Scott.
Good morning, Randy. Today we have a great guest with us, Mr. Scott McCarty.
Hey, Scott McCarty, good morning to you. What do you do at Red Hat?
I am a product manager in the container space. So our team builds like the technologies like Cryo and Podman and Buildah and Scopio and Red Hat Universal Base Image, which are then kind of added into OpenShift and RHEL, or part of OpenShift and RHEL, essentially.
Right. So today we're going to talk about UBI Micro. But before we dig into UBI Micro and some of the advantages it offers, particularly around security, maybe we ought to talk a little bit about what the UBI part is first, and how that fits into the overall system of containers and Kubernetes and OpenShift.
Yeah. So I always talk about the journey as like, when I first discovered Docker containers, basically, back 2013, 14 time range. The first thing you did was you installed this piece of software, then you pulled down a container image and you ran it and you were like, oh, wow, this kind of looks like a VM. I can imagine I could use this for all kinds of interesting things like looking up man pages on other versions of RHEL, which is what I used to do back then because I was a solutions architect. And people were like, hey, how do you run this clustered thing in RHEL 5? And I'm like, I don't know how to do that. I can't remember that at all. And I don't have RHEL 5 installed. So let me run this container image and do a man. And from there, I kind of had the epiphany. I was like, oh, wow, this is pretty cool. It like unlocks me, from these different versions. And so I realized the first thing that mattered was the container images, right? Like I need container images for like the different versions of an operating system to make it useful, essentially. And then eventually like want to build on it and build something useful because basically all software development is about collaboration and building something new and adding some kind of differentiated value. And then you want to share that. So in a nutshell, Red Hat, had historically had this sort of the way we do our end user license agreement. Servers weren't done like that. Servers were, I got the flour, sugar, eggs, and water and baked the cake myself. And then I shared it in my house. Containers is like, all right, I want to deliver pieces of the cake to everyone. And so like, we kind of had this tension between the way we monetized RHEL and the way we wanted to do containers. And so when we launched RHEL 8, we changed, we essentially released a subset of RHEL as free to redistribute so that it could be used in container images. And we called that UBI. And so Red Hat Universal Base Image. And we basically made, at the time, 3 base images, a bunch of layered images that were things like Python, Ruby, PHP, you name it, like all these different programming languages, Java, .NET. And then
all the usual suspects.
Yeah, all these usual. Technically, I'm lying about Java. It took us a little while to get Java out the door the way people wanted it. They were mad, and they didn't know that it was not on purpose. It was just logistics. Software's hard. And then the final thing, the third piece is we have a bunch of RPM repo, like a set of RPM repos that look quite stunningly similar to RHEL, but with a subset of RHEL in them that are out on a content delivery network, and they're freely available all over the globe, and they're very quick and easy to use, and you can basically bake the cake, basically add packages to the container base images or add packages even to the PHP one if you need it. And kind of that whole set of 3 things is Red Hat Universal Base Image. Although I think a lot of people refer to the base images as the UBI, it's really kind of all 3 things.
Right. So there's, to use an overused word, there's an ecosystem of things around UBI. And so if you're somebody who is familiar with Red Hat Enterprise Linux, RHEL, and RPM and some of the concepts associated with installing into an operating system and all of that, you can almost think of this as sort of a pared down version of that, is what it sounds like, right?
Yeah, that's exactly right. I think PaaS was really easy, not enough control. Just doing RPMs on a RHEL system was a lot of control, but not as easy. And like in the middle there somewhere is kind of like containers where you're like, I can do some of the things of the operating system I want to do. Mostly I'm focused on the app, but I can still do some of the operating system things that make it flexible enough that it meets like 80% of the use cases, maybe 90.
Right.
Well, but one of the things we've
Scott?
heard over years of software development and working with RHEL is that RPM packaging is hard, right? And so containers actually provides kind of a alternate method for packaging. So you can still use RPMs if you want. We provide all of our software as RPMs, but I mean, you could untar a tar archive into the file system of your container and then still pass it around as a single unit of software.
Yeah, I had a slide. I have actually, I think it's one of the container tidbits, something about secure supply chain or something like. I forget what I'd have to go back and dig up the article, but I published it a long time ago, like 4 or 5 years ago. But I joked because I have a pitch, or not really a pitch, but it's like one of my little rants there. I talk about, the Java guys. If you went back in time, back when I was a sysadmin, like around the year 99, 98, when I first started, and you'd be like, oh, you'd have the Java people, the Linux, Unix people, and then like developers on top of that. And by Java people, I meant like there was like Java app people that kind of like knew the infrastructure. And I'd laugh. You're like, your job as a sysadmin was like, go spin up the server. So I'd go spin up the server. And we used like CF Engine at the time, which is fine. It was config management. That was pretty good in the late 90s, I think. We were like on trend or pretty hip. And then at the time,
all the cool kids.
Yeah, all the cool kids were doing it. And then you'd hand it over to the Java guys, and they'd pull down all these tar balls. And I'm like, what are you guys doing? You guys are bananas. Like, I have no idea. Like, as a sysadmin that was pretty organized and could basically build reproducible builds, they were just like, no, man, it's cool. We just pull tar balls down. Like, the Java guys were totally hippies. And then the app developers were pulling down WAR files and running them inside an app server. So like, I remember about 2005, I was like, oh my God, this is horrible. But like, so we're all speaking different languages, right? Like mostly us sysadmins are speaking RPMs. Mostly the Java infrastructure guys are speaking like tarballs. And then the Java app programmers are speaking WARs. And you're like, this is clearly not going to work, right? So like the beauty of a container is you kind of boil it down to like, okay, we have this Docker file or container file that's kind of a blueprint that shows how to build this packaged thing. And we're all speaking the same language now. Now, in that Docker file or container file, I can go do whatever nasty, weird stuff I want to do and hide that from everybody else. Like, so the Java guys can go do their weird tarball madness, and the WAR guys can either deploy in the app server or dump it on the file system using like a Docker file. But now everybody has a container image that they can share, and there's kind of like accountability, and there's a blueprint for how we got from nothing to the end state. And so now we finally have kind of a blueprint, which is what I think we wanted 20 some years ago when I started.
Well, and you can tag it and other stuff so you can keep track of the version of that thing.
You don't do that with tar balls. You just pull them down.
Consolidated thing.
Yeah, exactly. Well, I would like to point out, as I'm old man yelling at clouds, that there was a time where there was a Red Hat product whose tagline was unzip and go. So that was a thing.
Wait a minute. What was that?
JBoss?
That was JBoss, yeah.
Oh, yeah. Okay.
That's still how they roll, I think, to this day. I mean, most Java guys are just like unzip and go.
Mm-hmm. Or at least that sort of application administrator part of the crew, as opposed to the application developers who are all about WARs and ears and all of that stuff, right?
Yeah, exactly. Yeah, so you realize there's kind of 3 different constituencies all speaking 3 different languages. Now the beauty of this is you have at least even in the Java world, you have all 3 of those constituencies speaking the same language. Now you can even have the PHP guys and the Ruby gals and the like all these different groups of people. They can all speak the same language, and it's not a language that's too complex. Like I think we love just enough, like to where it's just enough to kind of get everybody organized, but not so much that's oppressive. And I think that's why it kind of took off.
Yeah. Well, there's one other thing that has come up in discussions about, the thinking behind UBI, the universal base image, and that's something that you don't always hear about, and that's GPL compliance. GPL, of course, being that governing set of rules around the sharing of software that has been released under the GPL.
Yeah.
Can you talk a little bit about that?
Yeah, so that's one that we worked on for a long time, actually. Like we worked for a couple of years trying to figure out the right way to do this. And essentially what people don't understand is like, okay, so a couple of things about licensing. I think the hipster world has went to like Apache licenses and BSD style licenses where they're like, whatever, dude, we just put it everywhere. It doesn't matter. And they don't really think about attribution, even though technically they still are on the hook for attribution in a lot of these licenses. And then Red Hat goes above and beyond and pretty much provides the code for almost everything, basically, because the easiest way to attribute code is to just provide the code because the people's names are in there, that says what they did. And so attribution is basically saying, hey, this person wrote this code. That's attribution. Delivering the code is, the GPL. And so the GPL is the most famous one. But there's families of licenses, right? But Red Hat just goes above and beyond, goes all the way to basically the furthest one because it's just the easiest. And you deliver attribution and code at the same time, and you get both for the same buck. So what a lot of people don't realize is the GPL mandates that you should be delivering. So if you deliver a binary, you actually theoretically should be delivering the source code in like and kind, which basically means if you put it out on an FTP server, the binaries, you should have the code out on an FTP server. If you deliver a CD, like 1990 style to your customers, in Best Buy, then you should deliver the source code on that CD in that same box set, or at least through the mail in a fairly like and kind manner, right? Like it might take about the same amount of time to get it, and you get it in the same format, essentially. Well, what people didn't realize is when we went to containers and you dumped containers all over the world, and literally there's like a bunch of public registries at all the cloud providers. There's GitHub, there's Docker Hub, there's all these different public places. People are dumping binaries everywhere, and they are not attributing the code and not actually delivering the source code for basically everything that's out there. So there's definitely kind of a hairball out there that I think a lot of people aren't thinking about. And so we kind of thought, how could we make this easier, especially for our partners that like actually care about this and don't want to get in trouble or like have any kind of static or problem from this. And so we said, well, what if we could tuck source code in a container registry? And so this is becoming a very common pattern, by the way. So we looked at like what was going on in the Helm world, and they were starting to like deliver Helm charts in the container registry. We also are looking at, we're actually, this will get into the roadmap, but we're actually planning on implementing SigStore and doing that with Podman and with OpenShift. And that delivers the container signatures in the registry, which is beautiful because now I want to spin it up. I want to create the source code. I want to sign it all, and I want to shove all that in a registry. Like, that's beautiful. Now I have one place, like and kind. It's all the same. And so with UBI, we launched like this concept of source containers. And so with UBI, it's actually very easy to build what's called a source container. Actually pull down the corresponding source container for any base image that you pull from us, any image, actually, any of the images that are in the UBI family, pull them down, get the exact corresponding source code. So like, you're like, oh, the UBI Micro image only has these 27 packages in it. I want the 27 source, RPMs that go along with this. And I only want those. I don't want I don't want to deliver 10 gigabytes of source code just so I can deliver 27 megabyte, image. So you can find the like and kind corresponding, source code for all of our images now. And that's actually pretty cool. And then if you are an end user and you want to then go push those binaries out anywhere you want to redistribute them, you can also push that source code and say, hey, I'm meeting my obligation to the GPL. I'm meeting my obligation to attribution for BSD and Apache licenses and all the other blah, blah, blah licenses.
Wow. So, yeah, so it is. And, the thing about it is that sort of the compliance piece here is a thing that, as you mentioned, it's very easy to miss because, fundamentally, though, the high level story is all about sharing and caring, right? But there are some rules here. There are some things about attribution that are required. And so it's really fascinating to hear about how that's been factored in and addressed in this way that's actually very manageable and scalable, I guess is the way I'd call it.
I'll chime in one more thing since this is more of a conversation one. Like, I remember hearing, back in the day, I've been in this way too long, but I remember back when I was in the Python community a lot, and the guy that wrote Grails, it was like, it was a different language. I think that was in Ruby, but not Grails. It was one of the web servers the guy wrote in Ruby, and I remember he was an interesting cat. I can't remember his name off the top of my head, but basically he got annoyed because this other company he had released a bunch of code under like, I think it was MIT or Apache license. And they basically consumed all this stuff. And then they had customers and they're like, oh yeah, it's this upstream stuff. That guy screwed it up. And he's like, dude, it's the non-repudiation problem, right? They're like, they're like blaming it on this other guy that like gave them this code for free. And it's like, why are you blaming me for that? Like, what the hell? And so he literally swore he would never use attribution only code again. He would only release GPL v3 so that it was always copyleft. And then basically they had to release the source code and you could prove non-repudiate whose fault it really was. And so this open source, there are some of these edge cases that people don't realize, like when you're building your brand in this open source world and you're releasing all this code, honestly, kind of out of the goodness of your heart in a lot of ways, and then people start to blame you and attribute problems to you that are not your problems. That makes you kind of mad, and then so there's these things matter still, even in 2021. I don't think a lot of people realize.
Yeah, well, it comes down to accountability, right? So can you tell us something about the existing family of UBI images? Because there's actually multiples of these, or some variants, and then we'll maybe focus on our, we'll move on to our principal topic for today. But can we talk a little bit about the family of them and sort of why there's a family?
Yeah, so when we first launched UBI with RHEL 8, which is 2 and some change years ago, we launched 3. We launched a minimal, a standard, and an init container image. And we basically planned the standard was kind of the middle of the road one. We thought 80% of people would use that one. That looked like very similar to a Fedora image, very similar to a Debian image, an Ubuntu image. It just looked like a standard Linux distro image. It has Yum and DNF in it, blah, blah, blah. You can just pull down packages, install them. It works in a Docker file or a container file, and it's totally fine. The interesting thing was we created this other one called minimal because people were complaining about size. Everybody's trying to minimize size. There's this concept of attack surface, although I critique the way people apply this concept wrongly sometimes. But nonetheless, it is always wise to try to trim down the size of container images. So I remember Colin Walters was working on this thing called micro DNF, and I remember we were at a conference. He's like, I think I could knock this out by like this afternoon. And he literally worked on this thing and was like, I figured out how to basically install RPM packages with just a small C binary instead of pulling in Python and all these dependencies and blah, blah. So he was able to save like a couple hundred 100-ish megabytes, like maybe even a little more than that. I think he ended up saving like 120, 140 megabytes. So you're getting now like a 70, 80 megabyte image instead of like a 200, 210 megabyte image. And so we created this thing called minimal. And that was still good. It didn't have all the functionalities. So like in your Docker file or container file, you would need to kind of know the syntax of micro DNF, but it was pretty cool because you didn't have to have a full-fledged package manager in there. So that was kind of our first step on the journey is when we released that. And then on the other side, we had like the regular image plus systemd. And this is a somewhat controversial use case with some people, but I think they just don't really think about sometimes it's really nice to just do yum install MySQL, yum install HTTPD, systemctl enables HTTPD, systemctl enable MySQLD, and it just works. And you're like, oh, I don't have to know how any of this freaking crap works. I don't want to have SME knowledge on how to start MySQL right and collect, zombie processes and all these wacky things that happen. You're like, oh, you just run. There's this argument you run one process per container, which doesn't even make any sense because MySQL runs multiple processes in and of itself. Apache runs multiple processes. Nginx runs multiple processes. All of these things that people think are one process are actually multiple processes. So there's this sort of, So long story short, there's this argument. When should I run like multiple pieces of software in a container? When should I run multiple processes? Almost all the time, because almost everything's multi-process. And then when should I try to minimize and really truly only run one tiny little use case? And I've actually been thinking about this for a long time, writing a blog entry but it would require a lot of creating families of applications and showing people examples of these different things. But needless to say, we tried to create 3 different options to try to tackle a lot of different use cases that we think are pretty much the 99%. But then if you look in RHEL 8.4, we released something called UBI Micro. So now we have actually 4 base container images. So on the very tiny side, at coming in at 36-ish megabytes uncompressed and 12.5 compressed, which I think is pretty damn good. We have UBI Micro, but it has no package manager in it and none of the dependencies. It has a very, very minimal set of things like standard TZ data, standard, lang pack, not nothing beyond standard UTF-8 English language pack and things like that. Very minimized set of things in UBI Micro, and to install anything into it, you actually have to use the package manager on the host, or down the road, we're kind of looking at how we could use the package manager from a different container image to essentially remotely install packages on UBI Micro, but not actually install the package manager in UBI Micro, and then be able to deliver this thing that a lot of people call that a distroless image, because once it's baked, you can't add more packages. It's done. Even in production, you look at, there's nothing, you can't really muck with it. And they're usually pretty small, but there is still a dependency tree. There is still a C library. There is still an OpenSSL library. There are these, Apache, the quality of how it's patched still matters. Like all of those security things you would think about in that family of software still matters, but we do get it down to pretty darn small. I mean, I built an OpenSSL image is around 63 megabytes, and Apache image based on Micro is about 156-ish. I think Nginx is similar, 153-ish. So you're getting into a really small, tiny images that definitely compete with like Alpine in size.
Yeah, that's absolutely microscopic what you're describing. We've talked a little bit about things from the past. I can remember my second Linux distro ever was installed maybe 40 meg, and that was a long time ago. And that you think about now doing something in, was it 37 you said?
Yeah, 36.4, I think, if I remember right. I was just mucking with them yesterday, so I remember some of these.
That's unbelievable. So Micro really pares it down to the absolutely essential elements. We don't have the package manager in there, but there's some interesting approaches to getting packages in there. And even if you're doing something like Apache or Nginx or whatever, it still remains something that, if I think about how RHEL has grown over time, to think now about having a container usefully doing something at those sizes that you were talking is amazing, really. So quick question. Go ahead.
Oh, and Randy, I was going to add a little more color. So upstream in Fedora for a couple of years now, they've been working on this minimization effort to essentially go back and clean up the supply chain and trim down the dependencies. So in DNF, there's this concept of soft dependencies. These are RPM packages that you're like, hey, this RPM depends on this other one, but it's a soft dependency. Like you can actually have a command line flag in DNF to basically say, don't install the soft dependencies, only install the hard ones, where this software will actually break if this other thing's out there. But there's optional ones that, like, unless it's a full-fledged server, you don't necessarily care about, or maybe you want to pick and choose which dependencies you actually want to add. And so we're actually expecting the RHEL 9 base images for, the UBI 9 images will be actually even smaller. They'll end up, I mean, I'm not 100% sure yet, but we might get it down to like 5-ish megabytes compressed, 7-ish megabytes compressed. It'll be pretty darn good. Yeah.
That's unbelievable, but an interesting approach too, because there, as you say, there's the dependencies that it will not run if it doesn't have them, and then it's dependencies that are required to deliver certain features, but maybe you don't care about those features, right?
Yeah, there's no such thing as distroless. There's only somebody else's distro that you rely on. So even like the Google distroless project relies on Debian underlying for a lot of the dependencies. And so if you look, like if you're building a MySQL container, it's still a C program that's compiled against a C library. Let's be honest, nobody wants to maintain a C library, like if you don't have to. And then let's also be honest, this is the dirty secret that nobody wants to talk about in the container world. The C library is probably the most important library from a getting hacked perspective. Like if you look at most of the things that happen, there's a few entry points. There's the kernel, which now you're talking about the container host quality, but in the container image, the most important thing, the equivalent of the kernel in a container image, is the C library, basically. And so having a high quality C library that has a proactive security team that's like literally looking at it and analyzing it and double checking it, and a bunch of people that can commit code and fix CVEs and blah, blah, blah. That quality of that C library in my mind is probably a plurality of what's important in the container image from an attack surface perspective. You can have time zone data and all kinds of other like dead files that sit there and don't do anything, but you better be careful of that C library.
Absolutely. So just a quick question. So where and how do people get, these UBI images? I mean, how are they accessed?
Yeah, so the official place where they reside, like sort of the canonical place where they reside, is small c canonical. Place where they reside is on essentially a registry.access.redhat.com, which is an open registry that Red Hat runs where you can go and pull them. And then they're also now available on Docker Hub as of like May 20 something ish. I forget when those went live, but end of May we put them up on Docker Hub too. So basically you can get them anywhere, at your favorite neighborhood container registry. but mostly the
Cool.
Red Hat registry and Docker Hub.
So Scott McBrien, any thoughts, comments on the wonderful world of UBI? What are you hearing about it?
Well, I did want to point out that we maintain all those UBI images. So we rebuild them every 6 weeks automatically. And then we will kick off a spurious rebuild if something like a critical or important security vulnerability is discovered in one of the software packages that comes with it. If you look at the Red Hat catalog for containers and the UBI listing there, you can actually get access to the RPMs that are a component of it. We do a scoring of all of the containers that are provided through our registry that include things like open vulnerabilities, age, and some other factors, which is a little bit different than some other container registries that rate things by like number of downloads or number of likes people have given it over time. So if you are interested in more metadata about your containers from Red Hat, I think that the Red Hat registry is good. But I mean, Docker is kind of as McCarty said, the friendly neighborhood purveyor of container images. So we are there now as well.
Yeah, and like Scott said, those get synchronized every day essentially. So they're always up to date.
So there has been some chatter. I'm sorry, Randy. There has been some chatter in the chat since we have the principal product manager for containers here at Red Hat. So one person asked, what about doing hardened container images for people who want hardened container images? And my response was that if we made 1,000 different derivative container images, we'd then have to maintain 1,000 different derivative container images. But I wanted to get the hot take from Scott McCarty on it.
Yeah, and I'll say, like, I've looked at like a bunch of different, hardening guides, like the STIGs. There's like these STIGs. So government, I forget what STIG stands for. It's an acronym, but it's a famous federal government one that a lot of the federal government uses to harden systems and servers. And so there's a STIG. It's this set of standards for how to harden an image. The problem with some of these things is there's a bunch of problems with all these things. But the first thing is, if you harden all the images, like you said, you have two options. You can either have one for each of these flavors, which would mean we'll have like 10 different hardened images, or we'd have to pick a few. And then the third problem is like, once you harden them, they basically, security is always a trade-off of ease of use and more security. And so you got to look at, like, if I get a 1% improvement in security, but it's 99% harder to use, that's almost never, like, basically, SE Linux was probably like 4753 and people disable it all the time. Like, you get into that middle road where you're like, I know I'm a lot more secure, but I still want to. And so that's the problem with hardened images. And then another problem with them is like, some of them are just ridiculous. Like some of the, like, I don't want to name which ones, but like some of the ones are definitely, like, you look at them and they're checking for things that make sense on a server, but not in a container image and things like that. And so there's some spurious, like, little things where I'd call balderdash on some of the ways people analyze it that are actually trying to, for example, prevent problems with like the container engine as opposed to what's wrong with the actual image. And so, like, some of these things one could argue where it's better fixed. Like, is it better fixed in a container host with the container engine, or is it better fixed by like hamstringing the container image so it can't do things? And so, there's a lot of debate about where you harden these things. And so I would argue that, like, the Red Hat ones are hardened out of the box. Like, it's not like these things are not hardened. I would argue that our C library is hardened out of the box. Our kernel's hardened out of the box. So, like, like when a binary is compiled in RHEL, it has all of these, like, there's like 5-6 different security technologies, that we basically compile into those binaries, and all those binaries in there have that. The way we analyze the C library, it's hardened, like we have. And then on the host side, we're doing things like SE Linux. Our default profiles for SE Linux are actually very hardened. And so one could argue that, like, some of these hardened image things is like adding a 0.01%, it's a warm and fuzzy, but it's not actually providing you much value. And so that's the challenge. You're like, I want a safe minivan. You're like, this minivan is pretty safe. Like, and then it's like, how safe? Like, well, we could put big metal plates around the outside and then it'll look like a combat minivan. And like, like, it's like, how much, how far do we go?
Right.
And I will say that, like, the DISA STIG, for example, it's about servers. And so there's a whole bunch of things in there about like managing user access, which in the
Yes.
container world is not really applicable. And then also like depends a lot on the container host. Like if you're running rootless, then it doesn't matter that your container thinks that it has root access for running services or doing tasks, because on the actual host, it's not doing those things. Yeah. And then like if you're looking to have a more, or I should say a less attack surface thing, then just start with one of the smaller images like micro or minimal. And then you don't have to worry about network services and a variety of other things. They're not in there. And then if you have
Yeah,
to,
I mean, that's
you can
actually
add
what
them.
hardening often means, right? Is take all the stuff that you are not using out of there, right?
Yeah, I think a lot of people want a checkbox, and I totally understand why. But like, this is like you're like a 5-star crash rating. Like, what is a 5-star crash rating with a container image? I would argue, like you said, you want to build an Apache image that is super secure. Install Apache on top of UBI Micro with the glibc that we provide, and then update it all the time, every day. And that to me is about as minimal as you can possibly get with the highest quality components. And I would argue, there's nothing else in there. There's no system D. There's nothing.
Yeah, but clearly the next thing is like, but I don't want to update it every day. That's ridiculous.
Velocity is probably, I would argue, a huge part of attack surface. People don't understand. Trust is temporal. I try to explain this. The world rots around you every day. As you age, you know this better. I can testify to this. But like, the day you release a container image, it's great. But 3 months later, not so great. I don't care how good a quality components you had, because the world discovers new problems with the software in your container. And so, we're constantly discovering new CVEs, et cetera, et cetera. And so these CVEs build up on old software. And so velocity is a huge, time and space are linked. I hate to break this, but like, attack surface should be attack surface over T, because like it grows, right? Like as time goes on, and T is probably, I would argue, almost more important than an attack surface in a lot of ways. Or equally
That's
important,
really,
I would definitely say.
well, yeah. So along those lines, would you say that sort of the security aspects are one of the principal things that are bringing people to UBI Micro, or is it perhaps some of the other advantages that accrue to having this small, very tightly packaged piece? What is driving customers most? Is it the security thing, or is it, are there some other things that are maybe driving people to this particular choice?
I think it's a little bit of both, being very honest with myself. As a product manager, I have to be willing to, like, I have a technical brain and I have a business brain and I have a cool brain like everybody else. Like, I just want to do cool stuff sometimes. And I will admit that all three of those things have an actual effect on people. And if we don't admit that to ourselves, there are functional requirements, same thing, but there are also emotional and social requirements. Like, I mean, this is even in finance, we're starting to realize this, like with ESG and things like that. So like, if you're more honest with yourself about why people are selecting your product, you could do a lot better job. I think part of it is, to your point, it just makes you feel good. You're like, I know nothing's there. You remember the first time you ever installed a Linux server and you ran in production, and you're like, I remember the first time I was at NASA, and I had all these servers that were under my care or under my control. And we had these people, these hacking team try to break in. And the first year, nobody got in my servers. And I was like, yes, like that feeling that you get, you're like, I knew I minimized everything on those servers and it worked. Like, and mind you, is that the reason why they didn't break into my stuff? Who knows? Like, I could be getting the right answer for the wrong reason, but it feels good. So there is some element of like, it emotionally feels good when you know that you just don't have anything you don't need. I have to admit, I think that's about 33% of it. I think 33% though is attack surface. Like, I think it's reasonable to say, once you've standardized on a core build, like this is anything, I don't care if it's desktops, phones, laptops, routers, whatever. Once you've standardized on one version of a thing, so that truly minimizes your attack surface. That gets you from 27 different types of routers with 27 different versions of SSH running to like one router with one version of SSH running. That clearly limits your attack surface.
Well, I mean, if you think about how many lines of code, each line of code is a vulnerability, right? And so if you have fewer of them, then you have fewer lines of code.
Exactly.
And you have fewer vulnerabilities.
It's deduplication like storage, right? Like the less, the more deduplicated things you have, the lower your attack surface. So I think standardize first on one, and sticking it into container images, like purely standardize on a base image and then use that everywhere. And then within that, now optimize. Little o, big O is standardized. Little o, I would argue is then get down to things like UBI Micro and get rid of that, and then truly minimize the attack surface per workload. But really look at your entire environment first, I think is probably the most important thing. But yeah, so like getting back to, I think people do it partially for tech functional reasons, like, oh, our security. I think some of them are checkbox too, is the third thing I think it is. I think some of it is just like, hey, we need to check this thing. People said they need this thing. Let's check this thing. And then some people really do understand attack surface and actually have real good security requirements. And then other people just like the way it feels, I think is a big chunk of it. And I get that. I do appreciate that. I like Ferraris for a reason. I like Ducati motorcycles. Like there's a reason. Like Ducati's not better than my Suzuki, but yet I look at it and I go, that thing's a work of art.
I hear you. So, if somebody's interested in this, I mean, how do you dig into understanding more how to be effective with UBI Micro? Because I mean, the premise of it is to make things simpler, but any approach to making things simpler always requires some net new knowledge, right?
Yeah, I think containers are that in general. Like I think containers look so deceptively simple. I mentioned at the beginning, like when I first started using, I remember I went and built like CentOS 4, 5, 6, and 7 images at the time. This is back like 2013, 14. And I had them up on Docker Hub. And they became decently popular because nobody had built these things. I don't know why, but for me, I wanted them all because it was annoying. And I couldn't redistribute RHEL, so I couldn't create RHEL ones because our EULA prevented me from doing that. But I realized, like, okay, it's pretty easy to create a base image. But then as soon as you go to put an application in to a container, that's where you really have the smack in the face of, you're like, oh, this is really easy to use, like consume, but there's a tip of an iceberg as soon as you go to build one. So I don't know, maybe a year and some change ago, I published an article. I can share the link with you guys, but I put 3 different applications in containers, kind of using all the best practices I've learned over the last 7 years. And when you really look at it in action, I'm not going to lie, even I look at it and I go, this is a lot of brain power. Like, this is a lot of my own brain power. Like, I'm operating here at 90% CPU. Like, sometimes it was overheating. I'm like, this is a lot of work to like figure out, where do I put the config? Do I put the config on this volume to put the data over here? And I break these things down and use systemd. And I do use our init containers where I just fire up MySQL and Apache in the same container. And I run them read only, which is even funnier. You can actually run it with systemd read only. So, I mean, I've opened this to the world in good open source fashion, and no security person on the planet has attacked me about it because I did my homework. Like, I know this pretty well, and I'm perfectly comfortable putting it out there publicly. And I'd again challenge anybody to come talk to me about why the security is bad, or break into my server if it's that bad. I'd challenge. I mean, I don't know if it's that bad. Break into my server, but not that I want to challenge. I know somebody can figure out, but in a nutshell, I don't think it would be because.
Yeah, see, now I hear you walking it back.
I know I'm walking it back. Yeah, there's still always ways to get into servers, but mine would be pretty hard to get into. But again, the brain part that you got to put into it, though, it's non-trivial. So I would argue you need really strong Linux skills to do, early on we called containerization application virtualization, because you actually need to know the app to virtualize it. When you virtualize the hardware, you needed to know the hardware. You're like, oh, I need a network card. I need a video card. I need this much RAM. I need this many CPUs with this much power. That was hardware virtualization. And to do that, you kind of had to understand hardware, because you're like, hey, I'm going to put this app in a virtual machine. Now I need to know how much RAM, how much disk, how much, whether it needs a video card, whether it needs a, network card. Why does the network card need to be on this network, blah, blah, blah. That's hardware virtualization. But when you get into application virtualization, you need to know, where's the config for the MySQL thing? Where's the config for this Apache thing? Oh, the app that lives in Apache has this other config. I'll give you a perfect example. A really hard one that I thought deeply on for a long time is like WordPress auto updates itself. Okay, so like that seems like a really nice feature. I don't necessarily want to rebuild a container image every day and redeploy so that WordPress can like update itself, because it doesn't think WordPress was designed before containers. So it just wants to write to the home directory and just like basically change everything. So you're like, well, let me do a read write volume for this area where WordPress updates itself, but I'll do a read only volume on this config file because I don't want some hacker getting in and changing my config file, but I'll do a read only volume for this and a read write volume for that. And you got to like do a lot of architecture. And that basically takes senior Linux system admin skills. Like there's no other way to say it. Like when you're going to dig that deep into an application and deconstruct it and then put it in a container and actually limit what it can do and do it in a secure way, like it's harder than what people realize to do that. And so not all applications are good candidates for that. And then not all people are up to the task of doing it in a way that's sane and secure.
Well, I try to avoid too much pitchmanship here on the Level Up Hour, but I have to.
I kind of teed it up
a little
for you,
bit
though.
of a. You really did. It's one of those things that I think a lot of people want to skip straight to the glories of Kubernetes and containers and OpenShift. But underneath all of that, you do have to have those Linux skills. And we made a big change to the Red Hat Certified System Administrator program, a year or two ago, when we actually last year, now that I think about it, in which we said, knowing containers is part of what you need to be a qualified Linux system administrator, but it works in reverse too, is that you have to understand something about Linux. You can't look at this at a container as a black box. It's a convenient box. It's a tidy box. You can see what's in the box. And sometimes the work has been done for you about what's in the box. But at the end of the day, you have to understand a little bit about what goes into that box and why it goes in there to really be effective. And, nothing illustrates that more to me, to your point about understanding Linux, is that, if I look at pass rates on our OpenShift exams, people who are Red Hat certified system administrators do so much better than people who are coming in cold because they've been told, hey, you got to learn OpenShift, and maybe they haven't got those underlying skills. So yes, the container world makes for a lot of convenience and ease of use. Yeah, here, the whole metaphor of a container, like a container ship, and the revolution of container shipping is the same thing happening here, that you just drop your container. It sounds really good, and there is some truth to that, but you do have to know something about what's in the container at the end of the day, right?
Oh yeah, for sure. I would argue, so with application virtualization, aka containerization, there's three main skill sets you need. You need Linux skills, straight up. You need to know how config files work and where they go and how to mount devices and blah, 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 all the normal stuff that you would know with a Linux system. Then you need to have application specific subject matter expertise. So like, I know MySQL pretty well. I know PHP pretty well. I know Perl pretty well. I'm dating myself, but there's certain technologies I know pretty damn well still. I don't know Ruby that well. I don't know Node.js that well. Like to containerize Node.js would take me forever because I'd have to fart around and get this container. I'd have to get the application specific SME knowledge around how people run that best practice, how they lock it down, what modules they use with it, what things they use to administer it, how they get logs out of it. All these like operational things that somebody that knows Node.js or knows Ruby would just know how to do, right? And then thirdly, I need container specific skills. I need to understand the way a container engine works, the way you do volume mounts, blah, blah, blah. Once I know all three of those things, I can get an application in a container. Now the next set is, how do I run that at scale? Okay, cool. Now the Kubernetes stuff, in my opinion, is not actually as hard as everyone thinks it is. It's just they're trying to bite off all four things at the same time. They're trying to bite off basic container stuff, basic container tools, the app specific stuff, the Linux stuff, and then also run it at scale. And you're like, oh my God, I got to learn distributed systems along with all this. Yeah, of course you're going to get overwhelmed and fail. I mean, but if you look at it as four separate skill sets, you can start to say, okay, I do need these four skill sets to run Apache at scale and in Kubernetes. Like once I know how bind volumes work, PVCs and persistent volumes and persistent volume claims are actually quite easy to understand. Honestly, like the Kubernetes language is actually quite elegant, in my opinion. I think it's actually quite easy once you know what you want to do, but you need to know what you want to do first. And that's what I think most people don't even know what they want to do is the problem.
Isn't this why they want to pulling it back full circle to the concept of base image, right? Isn't this one of the reasons why organizations tend to operate around operations and developers and working together because like having one person with all the skills is super hard. And then that one person, like they're not portable. You can't clone them. So having people with really serious expertise in certain aspects of that operation or that development is key. And base images help you bridge the gap of that like Linux and systems expertise because we bring the Red Hat expertise. to that environment.
Building and managing a base image is a completely different skill set. Trust me, as a PM that has to deal with this every time we do a new dot release, versus like when I would use it when I was a sysadmin. I mean, I love using it. It's so much easier to use, but building it is a lot of work. I mean, the building it piece. So of course you don't want to do that yourself. Why would I want to ever do that myself? Like that piece is a pain. Just like, honestly, I don't want to build a Kubernetes distro from scratch myself. I don't want to do that. That's why I use OpenShift or I use a cloud provider, but I don't want to do it myself. Like in most cases, there's not a lot of business value in building your own base images. It's definitely better to leverage ours with our expertise. In my opinion, I think it's better to leverage ours and then leverage our expertise in the C libraries and the crypto libraries and all that magical stuff that you don't want to deal with yourself.
All right. Well, yeah. So I think there is a lot of truth in what you're saying. I mean, fundamentally, the thing that people have wondered about open source, and, we've all been asked this many times over the years. I'm sure I know I have. You guys have been in this for quite a while as well, look, if you can just download all this stuff and build it yourself, why not build it yourself? Well, because you're an insurance company. That's not what you're in business to do. That's not where you want your IT team spending their time, is figuring out how to build their own operating system. And that was our long time story around the operating system. And I think the same sort of story applies now in the world of containers and Kubernetes, and particularly to our subject today is, why not leverage the work of a known and trusted source rather than taking some of the risks that are associated with trying to cobble something together that maybe you haven't considered some of those factors around GPL compliance. Maybe you haven't considered some factors around the attack surface and some of the things that you might need to do to really ensure that you're using a highly secure image.
Yeah, why do landscaping companies buy dump trucks, and why do they pay somebody to maintain them and modify them and do all the things they do? They don't do that themselves. I mean, it doesn't make any sense. You're a landscaping company, not a truck maintenance company. And so, yeah, it's the same exact thing.
Yep. Well, actually, Hayes on the chat set makes a very good point. He says it seems easy to wander down the rabbit hole of thinking you need to learn this by building images from scratch. Yeah, maybe you actually start with some images that have been built and you understand that image very well. And I think one of the beauties of the way this works is you can start with that base image, and then you can start to dig into it and understand what those components are. And who knows, there probably are, those edge cases where you might need to do something from scratch, but better to be informed by having understood what experts have built from scratch first, right?
Yeah, and I mean, shout out to my old homeboys that I still love Gentoo. Like to this day, I remember when I went down the rat hole Gentoo, I learned Linux better than I ever learned in my life. I think it's a great learning tool. Would I ever run Gentoo in production? No, I would do that when I'm 24 because I was an idiot. But I wouldn't do that now. I would still use it to learn and run on my laptop and mess with. I mean, I don't have that desire now because I already know how a lot of these things work. But I still think it was like one of the most amazing communities ever, because you kind of had to work to get involved. And then all the people on the inside of the bubble were really good. So yeah, building a base image yourself to learn it. Absolutely. Building and then running in production, not so much, like I want to understand how TZ data works. I want to basically, how do I build a Linux distro? You get some of that knowledge and you kind of understand that. I think that contributes to the Linux skills that you need to truly know how to run apps in a container. That's cool.
So I don't remember who told me this early in my career, but they told me that open source is free if your time is worthless. Yeah. And so, you use other people's work, like leverage their expertise. And then that allows you to leverage your expertise without needing to bother learning all the things.
We've beat this horse pretty dead, but I will say, I thought I knew Linux pretty well until I became a product manager in the RHEL team. And then I started, I deal with Carlos O'Donnell and Florian Weimer and the glibc team. And I deal with Matt Newsom's team about Golang and this weird thing with this feature in Golang and that, and you start to realize how all these different pieces of software have to come together in this magnificent way to cause something to actually work right and actually make it work right for 10 years. So when I had to sneak my last features into RHEL 7 and then launch RHEL 8 around the same time, that was it's really hard. I mean, you have to interact with so many different teams, and these guys and girls know so much about specific things, about how seccomp works and why this one sys call is been deprecated because of this reason, because it had this weird security thing, blah, blah. And like the rat hole is so friggin' deep and it hurts my brain every day. And like, once you see that, and obviously I think any senior, principal sysadmin probably has some of this gut feeling. They're like, I don't want to know all this stuff. Like, I literally don't want to know this. I do, because I have to build the damn thing. And even I don't want to know it a lot of times. Like, I want these different SMEs to know it. And then I just trust their opinions. Like, honestly, I'm like, okay, if you say we should do this, let's do that. Sounds like it makes sense to me. Like, I mean, you have to be able to trust the people around you. Like, this is just basic trust.
Yeah.
So like, yeah.
Well, yeah. Do you want to have to be the expert in glibc, right?
Oh, geez, no.
To build
in
a
all
container.
These things. Yeah, it's funny because people think I am. I'm like, no. I am not even close. I have like 10% knowledge in glibc. It's just the average human being has like 1% knowledge. So mine looks really impressive. And then when I talk to these guys, I know nothing. I'm like, I have no idea what I'm talking about.
Well, so quick question. Were we wanting to perhaps do a little demo? Were we wanting to take a walk on the gangplank and see how that goes?
Yeah.
Mr. McCarty?
It is getting close to the top of the hour.
Oh, it is. You're right. I just realized
we need the sweet internet points.
Well, we are getting close to the top of the hour. I don't know how much time we require for a potential demo, or are we going to bail on the demo?
I could do a quick 3 minutes. How brave is Scott McBride is the question. I think I can build an open
stupidly brave.
I think I could build an OpenSSL image with Buildah in like 3 minutes.
Yeah. See, I think we go for it, and I will discuss the sweet internet points if I have to interrupt. But I think we are going to go for it here. And while I'm thinking about it, we have to acknowledge the prom dress moment here. That Scott and I are both wearing our level up our swag. So anyway, let's go ahead and give this a shot.
Yeah, let me share. All right, so you'll see on the system, I just have this tool, Buildah. This is a RHEL 8.4 box, and then if you look, I'll have Podman images here. I have, let's grep micro. You'll see I have a UBI Micro image here. This one's been pulled down. So it's actually quite simple to build on UBI Micro. It's like one command, Buildah from, and then we'll like grab this guy right here. And then you'll see what it does is Buildah has created an instance of a container here. This is like its internal representation of what a container is, because it's not defined in the kernel. It's defined in the user space. So like Buildah has its representation. Podman has its own. Now I can do like a Buildah mount. And what this will do is it's like, okay, there's this container, but now let's mount the storage on this container. And then I can do a yum install. So let's like, look at this guy. So what I'm doing here is I'm saying, I'm using this complex yum command that's actually not as complex as it looks. The magic of this is this install root. I'm using the yum on the underlying container host on this RHEL 8.4 box to basically install into this install root, which is the directory that Buildah command gave me back. And what that is that's a container, essentially. That's a root file system. If I go out here and I look at this bad boy, let me do this real quick so you can see. This is a root file system. Like, it looks just like a server. And so if I run this command, what I'm going to do is I'm going to build OpenSSL. I'm basically going to install OpenSSL out into this directory on top of, I think I screwed it up. That's what I thought I did. Let's do this one more time. What I do.
So earlier we were talking about like placing files within the base image. And that's essentially what you're doing here is you're using yum on the host to unpackage those files from the RPM and then place them in the file system within the container image.
Yep, that's exactly right. And you see it looks like a normal install because there's already an RPM database in UBI Micro. So what it's doing is it's saying, hey, I'm going to install these packages and then add them to the RPM database in the UBI Micro image. And you'll see it's 36 packages because dependencies, there's a decent number of dependencies, but you're actually going to be surprised that this is not that big. These are pretty small dependencies. There's nothing crazy in here. And
well, I'm seeing a lot of that listed in KB, right?
Exactly. We've done a pretty good job of minimizing these, and like I said, we're working on even more in RHEL, but in RHEL 9, but like it's decent. This is pretty good. I'm pretty happy with, you'll see here when this thing should finish pretty quick. I think we'll be real close to a 3-minute mark. But you see glibc, some glibc things. You start to get a feel for like the kinds of things that get installed here. CA certs. This should take 1 second. Boom. And now let's do a commit. So if you look, I think it was UBI working container, I believe was the one. Yep, there it is. So I just committed that bad boy, and then let's do a Podman images. So what this did was this wrote it as UBI 8 Micro SSL, and then we'll do a Podman images, and we'll look for UBI 8 Micro SSL. And actually, this is saying, it's saying it was only 38 megabytes. I don't buy that I only created. That's interesting. For some reason, it's saying that I only added 2.6 megabytes to that, which seems strikingly fishy because I could have swore the last time I built it was 63. Something's going on with my file system, I suspect. But nonetheless, it's pretty darn small.
Well, is that compressed size or uncompressed size?
That should be uncompressed on the disk there. Yeah, that's interesting. Yeah, I don't know why it's so small. I would think it would be about 60. Wow, look at this. You can see here, like, what were these things? 1 point. That's pretty small. So maybe we had a dependency torn out somewhere, but this is 2 megabytes.
Yeah.
That's 25. That should have added more than that. But I don't know. I don't think that's actually 25 though. I think it's compressed on disk. Yeah, I don't know. That's an interesting one. Something wacky with my tools going on there. I think I want to say the last time I built this, it was about 63 megabytes, but nonetheless, pretty darn tiny. Here it's showing I only added 2.6 megabytes, which, hey, if somehow somebody made something that made this, or somebody fixed something that changed the dependency and made this smaller, I'm even happier. But yeah, that's UBI in a micro in a nutshell.
And so question is it the case that you might discover that when you build something that you've built before, that perhaps additional optimization and improvement will have happened in terms of the size of the image?
Yeah, absolutely. And it's a place where we're focusing on, and it's a place where if it doesn't break something, we might do. And you'll notice I had in that command, I had some optimizations in that yum install. So I had set opt install weak depths equal false. So if people had updated their weak depths list, even in RHEL 8, this would change over time. So since I'm using an optimization, I would pick up those optimizations. So yeah, that is exactly right. And in RHEL 9, I should pick up even more when I essentially run these. I'll do a RHEL 9, version of this, and then you'll see that it will end up being, it'll be even smaller in RHEL 9 because there's more optimizations in the dependency tree in the later versions of Fedora and then RHEL 9.
Quite the teaser. So with that, it's time to talk about those sweet internet points. And we have a really, really tight race here on the points. Narendev, of course, at 6,300, but NLHACM at 6,200, and some other leaders on the leaderboard here. So in order to get into the sweet internet points, the SSIPs, hit one of the URLs below that you can see in this, and I think we might also post that into the chat, and that's how you can perhaps try to get on the board, maybe even catching up. Good luck with Narendev. And so just last word here. Thank you, Scott McCarty, for joining. This has been enormously informative and fun. Thank you, Stabby, as always. And thank you, everybody, for watching and listening. Make sure to like and subscribe. Share it with your friends. Tell your family. Your grandmother is especially interested in this stuff. So until next time, thank you for joining the Level Up Hour.